Okay, let's just jump right into it. We're talking about one of the biggest, if not the biggest, challenges humanity has ever faced, decarbonizing our entire world. It sounds huge, I know, but understanding the plan is the very first step. Take a look at this number, 42.4 billion. Let that sink in for a second. That's how many tons of carbon dioxide we, humanity, added to the atmosphere in 2024, just 1 year. It's a number so big, it's almost impossible to wrap your head around. So, you gotta ask, right? How on earth did we get here? And maybe more importantly, what in the world do we do about it? That's exactly what we're going to break down. All right, first things first. Before you can solve a problem, you have to understand it, really diagnose it. So, let's talk about our carbon overload and how our planet's system got so out of whack. Yeah, you hear about a bunch of different greenhouse gases, right? Methane, nitrous oxide, the whole gang. But this chart tells the real story. They all play a part, sure, but CO2 is the undisputed heavyweight champion here, causing a whopping 2/3 of the problem. It is the absolute core of this thing. And get this. This is what's so wild. CO2 is just a tiny, tiny fraction of our atmosphere. We're talking 0.04%. But it acts like the world's most powerful heat-trapping blanket. Even the smallest changes to that tiny percentage have these massive, massive consequences. You know, you sometimes hear people say, what about volcanoes? Well, let's just look at the data. All the volcanoes on Earth combined spit out less than 500 million tons of CO2 a year. Humanity, we're pumping out over 42 billion tons. It's not even in the same league. Not even the same sport, really. This one's on us. Okay, so we've overloaded the system. So what? What does that actually mean for us, for the planet? This is where we get into the stakes and why this is so incredibly urgent. Just look at this timeline. I mean, wow. For 800,000 years, 800,000, CO2 levels just bounced around in this nice, predictable, safe range. They never went above 280 parts per million. And then, bam, look at the far right of that chart. That's not a hill. That's a vertical wall. We have skyrocketed past 420 ppm, a level our planet has not seen for millions of years. And what did 420 ppm mean in Earth's history? Well, the last time there was this much carbon in the air, global sea levels were 75 to 100 feet higher than today. The only reason many of the world's biggest cities aren't underwater right now is because our massive ice sheets are acting like a temporary dam. And don't think for a second this is some far-off problem for our grandkids. It's happening right now. The data is crystal clear. Since the 60s and 70s, we've seen extreme tropical storms double. The frequency of droughts doubled. The area burned by wildfires in North America, you guessed it, doubled. The effects are here, and they're picking up speed. And then there are these huge, scary risks lurking in the system. Scientists are getting really worried about something called the AMOC. Basically, think of it as the planet's circulatory system, a giant ocean current that moves heat around and keeps our weather stable. If that thing shuts down, we're talking about plunging Europe into a deep freeze and causing just absolute chaos for weather patterns worldwide. Okay, I know, that was a lot of doom and gloom, but it's absolutely crucial to understand the stakes. Now let's pivot, because that is not the whole story. Let's talk about the good news, the incredible, mind-blowing innovation revolution that's happening right now. This is where we find the hope. Let's kick things off with a huge one, cement. It's responsible for 8% of all global emissions. That's massive. But check this out. Innovators are totally flipping the script. Companies like Blue Planet and Concrete for Change are figuring out how to turn CO2 into building materials. So instead of being a huge polluter, concrete could actually become a carbon sink. How cool is that? And it's the same story for steel. For like forever, making steel has meant burning tons and tons of coal. But that era might be ending. In Sweden, a company called SSAB is already making the world's first fossil-free steel. They're using hydrogen created from renewable energy. This is a total game changer for heavy industry. And seriously, the list just goes on and on. We've got companies making carbon-neutral jet fuel from sunlight, others creating protein-rich food from just CO2 and electricity, literally food from thin air. We've got people capturing carbon to make everyday products like vodka and perfume. And then you've got Climeworks in Iceland building these giant machines that just suck CO2 right out of the sky. The innovation is just exploding. But of course, none of this works without one key ingredient: clean energy. This brings us to the most fundamental challenge of all. We have to reimagine our relationship with energy. We need to forge a new fire for our civilization.
Okay, so you hear the word hydrogen thrown around a lot. It's supposed to be this miracle fuel, right? But here's the thing. Is all hydrogen created equal? The answer to that is a hard no.
And this is a really, really important distinction to get. You've got gray and blue hydrogen. Both are made from fossil fuels. They either pollute directly or they rely on this sketchy carbon capture tech that isn't really proven at scale. The only one that's a true zero-emission solution is green hydrogen. It's made by splitting water with clean electricity. That's the real deal. Now, what about biofuels? Super important for things we can't easily electrify, like airplanes. For years, we've used corn, but it's just so inefficient. You get maybe 28 gallons of fuel for an entire acre of land. But now, compare that to new biofuels made from algae. They can produce up to 5,000 gallons per acre. That's the kind of insane leap in efficiency we're talking about. So let's pull it all together. We've seen the problem, we've seen the terrifying stakes, and we've seen the incredible solutions that are already here. It really all boils down to one thing: a choice. The path forward is actually pretty clear, but we have to decide to walk it.
So what does the plan look like? It's basically 4 big moves. 1, we go pedal to the metal on renewables, solar and wind everywhere. 2, electrify everything. Cars, heaters, stoves. If it can run on clean electricity, it should. 3, for the really tough stuff, planes, ships, steel, we unleash those brilliant innovations like green hydrogen. And 4, we have to clean up the carbon we've already put up there. We have to scale up the tech that can pull CO2 right out of the air. It's a full system upgrade.
And let's be brutally honest about where we are. This is the bottom line. We're already at 1.5 degrees Celsius of warming, and you can see it wrecking our planet every single day on the news. The time for kicking the can down the road is over. Any more delay risks pushing us past tipping points that we can never come back from. So that leaves us with this one final, massive question. When future generations look back at our time, what will they see? Will they remember us for overseeing the 6th great extinction? Or will they remember this as the moment humanity chose a different path? The dawn of a new clean energy world. The science is in, the technology is here. The choice is ours.